Hello, welcome back to Science Terminology. Today we're going to talk about stars. Stars, right, just plainly are just giant balls of gas, but they're a little bit more than that, so we're going to talk about the things that make stars so important. So what is a star? A star is a large incandescent ball of gas, and those gases are hydrogen and helium. And that gas ignites due to its own monumental gravity. So gravity forces these gases together, and they become so hot that they ignite and they start fusing. And we'll talk about what that means next. There are many stars in our galaxy, and even more in the entire universe, right? So stars are everywhere. If you look up at the night sky and there's no light pollution, you can see how many there are. There's thousands and thousands and thousands. And the suns, right, which are stars, provide energy to the rest of the universe through the process of fusion, which I mentioned just a second ago. So let's talk about what fusion is. Nuclear fusion is when two nuclei of an atom are fused together to create a new atom. Now, this has to happen at incredibly high temperatures, so it is not it's not something that can be easily done. But this process also releases a monumental amount of energy. So the energy released from this is just massive. Basically, two hydrogen atoms are fused within the stars, and the products are a helium atom, a neutron, and then energy. So I have a little diagram here that shows that. This one here is a hydrogen with two neutrons, and this one here is a hydrogen with just one neutron. And when they fuse, you end up with a standard helium atom, and then that extra neutron goes off. So now we're going to talk a little bit about the life cycle of a star, so you kind of understand how stars go through their life. So let's get going with that. So at the beginning, all stars are born in what are called a stellar nebula. Okay, particles and gases coalesce around some central point of gravity. And then when these gases and particles come close enough together and there's enough pressure and heat being generated from them being so close, the fusion process will ignite and then a star will be born. That's where they're made, in these stellar nebula. Now, there are different kinds of stars. Obviously, they can come in various sizes, and they've been sort of categorized into two different types. There's kind of your average star and your massive star. Okay? Average stars have an initial mass of about half of the size of our sun to 8 times the size of our sun. So they can be smaller than ours, or they can be much bigger. And the average stars often shine more of a yellowish orange hue. Now, these average sized stars can live to be about 10 billion years old. That's a long time. Massive stars, on the other hand, can be up to 150 times the size of our sun. That's just absolutely massive. And these massive stars burn through their fuel much quicker, so they don't end up living as long as average stars do, because there's so much more fuel, and because there's so much space that it's taking up. That means there can be more interactions, and so the fuel is burned through a little bit quicker. These massive stars can be up to 500,000 times more luminous than our sun. So imagine how bright our sun is, multiply that by 500,000. That's how bright these stars can be. They're incredibly luminous. Now, after a long portion of their life, stars end up expanding when they begin to run out of fuel. Now, an average star turns into a red giant, and these stars expand and become duller, right? They're not shedding as much light. Red giants are not as warm, but they are unable to hold these particles as close, and so the star expands, right? The gravity is weakening, they can't keep all this stuff together, and so they expand. Now, massive stars become red supergiants, so even larger giant stars. And these supergiant stars are the most massive by volume, but not the most luminous, right? They're not expelling as much light or energy as these other stars are. And they are rather cool for a star, having a surface temperature below 4,000 Kelvin, which is about 6,000, almost 7,000 degrees Fahrenheit. So that's cool for a star, right? That'd be really warm for us. Now, finally, when these stars do die, the next step for each are here. An average star will form what's called a planetary nebula. And now, this is kind of a weird name for it because it doesn't actually have much to do with planets. But planetary nebula basically just consists of this expanding, glowing, ionized gas. And these nebula expel higher level elements across space, and that kind of assists in the chemical evolution of the universe. See, stars, at the end of their lifetime, the fusion ramps up, and the helium atoms end up becoming other elements. So the higher proton level elements are created in stars. They're basically crucibles to create stronger, higher elements. Now, the supernova is what happens to massive stars, and supernovae are just really powerful luminous explosions. So basically, if your star is large enough, it explodes. Now, supernovas are luminous, and they can be as bright as an entire galaxy before they fade away, which is intense, right? A whole galaxy worth of light, all in just one star's explosion. Now, finally, for an average star, after it becomes a planetary nebula, these average-sized stars will end their life at what's called the white dwarf stage. And white dwarf stars are just very dense. They release much less light, and these white dwarf stars are normally composed of carbon and oxygen, but sometimes, depending on the size, it'll end up fusing some neon and magnesium, and you'll end up getting an oxygen, neon, and magnesium white dwarf. So there's a couple different types. Now, if you're a massive star, you've got a couple different options. The first one being becoming a neutron star. Neutron stars form from stars between 10 to 25 times the mass of our sun. So, okay, our sun is not big enough to become a neutron star. It's going to be a white dwarf. They are the smallest and densest stellar objects, excluding black holes, and these neutron stars are thought to be composed entirely of neutrons, which is pretty interesting. Something that large being made of just a subatomic particle is pretty cool. Now, on the other hand, if it's even bigger, it can become what's called a black hole. And black holes are regions of space-time where gravity is so strong that not even light can escape it. So nothing can escape the gravity of a black hole. Okay? Now, the region where things can no longer escape under the enormous gravity of a black hole are called event horizons. Okay, so once something passes the event horizon, it is doomed to be sucked into a black hole. Do we know what happens when you get sucked into a black hole? No, they're far away from us. We don't know what happens. All we can do is think or postulate about what happens inside a black hole, but we don't actually know. So maybe one day we'll find out. That'd be pretty interesting to know. Here's a nice little overlay of the whole process, just so you've got a nice little picture to go along with it. So you can see all of the different parts there. Now let's talk about our star, the center of our solar system, the sun. All right, so the sun, right, center of our solar system, it provides all the energy to our solar system and to our planet. And that's because the sun can fuse 600 million tons of hydrogen every second. That's a lot of gas. And it takes roughly 10,000 to 170,000 years for that energy produced in the sun to reach the surface of the sun. So it takes a long time for that energy created in the center to get to the outside. And then it takes about roughly 8 minutes for that energy to get from the sun to us afterwards. So the light that hits us every day on the planet is actually, at the minimum, 10,000 years old, which is pretty intense, right? You're getting hit by 10,000-year-old light. Pretty cool. Now, what's going to happen to our sun? Well, at the end of the sun's life, in about 5 billion years, okay, the sun will begin to exhaust its fuel and become a red giant star, right? It's an average-sized star. And the sun will grow large enough to engulf Mercury and Venus, okay, the first two planets in our solar system. So those planets will be encompassed within the sun, and it's going to make the Earth uninhabitable. Okay, so at that point, in 5 billion years, life on our planet will cease to exist because it'll become so unbearably hot that nothing will be able to survive. After the red giant phase, the sun will then shrink down and become a white dwarf star, and at that point, our solar system will no longer really be the same forever because of those changes. Thank you so much for watching this science terminology video. I hope you're enjoying these videos and learning something from them. If you are watching them, please subscribe. It really helps me know what kind of things the channel needs, and it'll help me out. So thank you so much. Hope you're having a good day. See you in our next video.